On the Robotics education site, you'll find a download for the code we're about to talk about. If you're watching this video on YouTube, go to the description to find a link to this page. I'm going to first download this Java example and drag it into Android Studio, and then we'll talk about what it does. I'm going to click on the link to download. I can see it downloaded here. I could also find it in my downloads folder, or I can just drag it from my internet browser. I have Android Studio open. I've browsed to the team code folder, or everywhere else I'm keeping my user programs. I'm going to take this code and drag it from my browser into my team code folder here. It's going to ask if I want to fix any names or rename it. I'm going to keep that name the same and say OK. It says I already have it. You probably won't say that. I'm going to say overwrite. And there it is. Let's go ahead and talk about this program. This first program runs a motor at constant power. The motor is going to receive always the same amount of power from the motor controller. The motor controller is turning the power on and off at a high frequency, but it's always going to do that at the same frequency when using this mode. Here we are setting the mode. We're saying that the run mode we want to use is run without encoder. That's the equivalent of what in modern robotics calls run at constant power. So first we had to declare our motor. Since we only have one motor, I just called it motor. So I have my DC motor named motor. We also need to map that motor. So the motor I'm going to call ML. It's short, it's easy to type in. I don't need to do any other clicks other than an M and an L when I do my configuration file. Then we're going to set the mode, and then we'll wait for it to start. The power can be between -1 and +1 and have decimal places. The power only has a resolution of 0.01, so any decimal places beyond that won't get you any more fine tuning. 1 is going to be full speed forwards or clockwise, and -1 will be full speed in counterclockwise direction. So here we're going to go forwards at 15% power. So as soon as you hit the start button, this program is going to set the power to be 15%, and it's just going to stay on. The entire body of the program is just going to tell you what mode we are running, so we're running at constant power. It's going to tell you what the power is, and it's going to bring you back the encoder position so you can see how fast that's changing. And then this update is going to push those out to your driver station. We're using here motor.getPower instead of just saying 15, because that is going back and grabbing what the power is from the motor instead of having it be a different input. For example, here, if we took this 15 and change it to a 20% power instead of 15% power, it's now going to display 20% power here instead of 15% power instead of having to change it here and there. So that's kind of nice. While that mode is active, it's going to continue displaying the power and the encoder position. When we press the stop button, it's going to exit this loop because our op mode is no longer active. When we exit the loop, we want to turn off the motor. So we're going to say motor.setPower to 0. That's going to turn the motor off.